All right, let's get right into it. We're going to talk about a piece of safety gear that honestly we all just take for granted, the lifeboat. It's supposed to be the ultimate symbol of rescue, right? But what if I told you that the very thing designed to save us has, in a weird twist, become one of the biggest dangers at sea?
So here's the question that gets thrown around a lot in the maritime world. It's a shocking one. Now look, there's no single global statistic that can definitively prove this, but the fact that this question even exists points to a massive, long-running problem. The truth of it all is so much more complicated and, frankly, way more fascinating than you'd think.
And this just perfectly captures the whole dilemma. On one side, you have this UK study over 12 years. The findings? Lifeboat incidents caused 12 deaths and 87 injuries, with zero, and I mean zero lives actually saved in a real emergency. But then, on the other side, you get one single event, like the Sun Vista cruise ship evacuation, and bam, over 1,000 people are saved at once, with no fatalities. It really shows you how one successful use case can justify their existence, even while these smaller, but much more frequent accidents just keep happening.
So how in the world did we get here? Well, it all goes back to the original design, a system that seemed simple enough, but was hiding a really fundamental and really dangerous flaw. The old system was just pure manual labor. Seriously, you'd lower the boat down until it was actually floating in the water. That would take the weight off the heavy cables, those are called the falls, and you'd get some slack. Then, a crew member at each end of the boat had to literally, physically unhook them. Now that sounds fine in calm water, right? But imagine trying to do that in rough seas. The boat is getting violently jerked up and down. Trying to get your hands anywhere near those massive hooks, it was next to impossible and just incredibly dangerous.
And this disaster was the breaking point. It made it painfully clear that the old system had to go. When the Alexander Keeland, which was an accommodation rig, collapsed, well, there were plenty of lifeboats, but people died because those boats, getting smashed by waves, never floated enough to take the load off the falls. The crew just couldn't unhook them. It was obvious a new system was needed, one that could release the boat no matter what the conditions were.
So this led to a really ingenious engineering solution. But as we're about to see, this brilliant piece of design also introduced a totally new and fatal risk.
Think about this for a second. This was the core engineering puzzle. You have a hook that has to be strong enough to hold a fully loaded lifeboat, and we're talking about the weight of maybe 150 people hanging from it. But at the same time, it also has to be releasable while it's holding that exact same massive load. I mean, how do you even begin to design a system that can do both of those things?
The solution is just a brilliant use of basic physics. You have a specially shaped piece of metal called a cam and a long lever. Together, they work to multiply force like you wouldn't believe. It means a massive load on the hook can be held in place by just a tiny little locking pin on that cam. So, a simple pull on a release lever rotates the cam, the hook pops open, and it doesn't matter how much weight is on it.
And right there, that is the new problem. The system that solved the issue of releasing the boat in the water created this terrifying new possibility of releasing it by accident, say 100 feet in the air. So in solving one deadly problem, they had literally created an entirely new one.
This fundamental flaw kicked off what was basically a decades-long cascade of fixes. Each new fix was designed to solve the problem created by the last one, and every single time it added another layer of complexity, and with it, a whole new potential for failure.
You can see this frustrating cycle right here. First, you've got the problem, accidental release. That leads to fix number one, let's add safety pins and automatic interlocks. But, oops, those new systems bring in new kinds of mechanical failures and human error, so that leads to fix number two, fall prevention devices. It's like a technological arms race against our own mistakes.
Okay, so the first big idea was to try and automate safety using something called a hydrostatic interlock. It's basically a little sensor on the bottom of the lifeboat, and if that sensor isn't in the water, it physically blocks the release handle from working. The theory was great. It should be impossible to release the boat while it's still in the air.
But of course, this new technology brought its own set of failures. The sensors could get clogged up with grease during a drill, for example, and then they'd just stay in the unlocked position even after the boat was hoisted back up. Different companies use different color codes, totally confusing the crew. And, as the Thunt Duke incident tragically showed back in 1992, if that cam mechanism wasn't reset perfectly, it could just fail under load, which led to 6 deaths.
So what did the industry do? It added yet another layer of safety, fall prevention devices, or FPDs. These are basically a last resort manual override. It could be a super heavy-duty strap or a solid steel pin that physically locks the lifeboat to the davit. That's the crane arm that lowers it. It completely bypasses the entire complex hook system altogether.
And here's the crucial point. We've just traded a complex automatic system for a complex manual one. So now, in the absolute panic of a real emergency, the crew has to remember yet another critical step. You have to remove the FPD before you can launch. And that brings us to the real heart of the whole problem.
Yeah, after all these mechanical fixes, it started to become really clear that the problem wasn't just about cams and sensors and pins. The problem was us. It was about people.
This is just a classic case of what they call human factors engineering gone totally wrong. The technology, as clever as it was just fundamentally incompatible with the way human beings actually behave. Instead of designing an intuitive, simple system, we just kept patching flaws with more and more complexity, which just made it even harder to use correctly when you're under extreme pressure.
And this slide, wow, it just captures the tragic irony of the last 100 years of maritime safety. Back in the Titanic era, people died because there weren't enough boats to escape on. Today, we have plenty of boats, but now people are dying because the boats themselves have become so dangerously complex.
The end result is just unbelievable. We've created systems that are so complicated that the very people who need to use them are getting hurt and even killed just trying to learn how they work. The weekly lifeboat drill, something that's supposed to ensure safety, has actually become one of the most hazardous jobs on a modern ship.
You know, this whole story forces us to ask a really difficult question, and not just about lifeboats, but about safety design in general. At what point does adding one more failsafe, one more backup, one more procedure, at what point does that stop making us safer and start creating a system so complex it's just waiting to fail? That is a question the maritime industry is still grappling with, and it's a paradox that goes way beyond the decks of any single ship.